Hi, I'm the Excellier. My name is Geert-Jan Mulle, and in this video I'm going to show you my take on how to generate all possibilities in a combinatorial mathematics context. Generate all possibilities for repeat variations, combinations, permutations, and a little bonus at the end. And I'm going to use Power Query to do that. Before we're going to jump right into it, I'm going to explain what are these things, repeat variations, etc. For that, I'm going to use the so-called VAS model, oh man, how to pronounce the word? Well, online you can find many videos how to say this word, and in British English it's vase, and in American English it is vase, and I'm going to avoid that problem altogether, and I'm going to replace the container with a box. Voila, there it is. The box model, officially called the vase or vase model. What is it? Well, it's a blind box. We don't want to look inside, and we want to keep an element of randomness involved here. And we put inside that blind box n elements. Think of them as numbered balls. N elements. What do we do with it? Well, we pick balls from the box one at a time, and in a sequence we perform k amount of picks. So it's a general case, n elements, and we pick them k by k. In order to determine the exact metric, we need to answer a few questions. Two questions are very common here. The first question is, do we return the ball to the box after each individual pick? Yes or no? If we do, we talk about a metric with repetition, or a repeat metric for short. If we don't, we just call it, well, the name of the metric, or you could call it the ordinary metric. In any event, it is the metric without repetition. The second question we need to ask ourselves is, do we keep the sequential order of the picks or not? And in the second case, we could sort the numbers. So if we keep the sequential order, we talk about a variation. If you apply a few more restrictions, we get permutations. Yeah, if we sort the sequence, so we don't keep the sequential order, we talk about a combination. Now, what are we going to do in this video? We're going to generate all possibilities for these metrics, repeat variations, combinations, permutations, and as a bonus, derangements. The latter here I will define when we get there. By the way, repeat variations or variations with repetition, as mathematics calls them, in Excel they are called permutations with repetition, but technically that is not the right term. So I'm going to keep the term repeat variations. If you think those are the most abstract things we're going to encounter today, we never use them in real life, well, you'd be wrong. Because for repeat variations, the most simple of all examples are the numbers we use on a daily basis. Okay, the digits of all possible numbers up to a certain magnitude, yeah, where n, the number of elements here, is just the number of possible values for the digits. In mathematics we call that the base, and k, the number of picks, is the number of digits itself. So we can easily take that into account. It helps us to generate those repeat variations. For combinations, well, we can do that. You can use some lambdas, but they are quite inefficient, at least mine are, be it recursive. You can do it, and you can sort the table a little bit like this, and you can look at these nice combinations and derive the necessary rules that you need to apply in order to generate them. That's what I did, and we have permutations here, and finally the derangements as well. Now technically we haven't written those Power Query functions yet, so you know what, let's get to a new workbook and start writing those functions from scratch. Okay, here we are in a new workbook. Let's open up Power Query. In Power Query, let's start a new blank query. And I'm going to give it a name, generate all template. I'm going to create a generic template first. I will reuse that template for all the subsequent functions. That makes it most efficient. Alright, so n as a number, general case, k as a number, result as a table, goes to. The main function we're going to use is called list.accumulate. Right there. We're going to iterate over the columns 2 to k. Why do we start from column number 2? Because the first column is going to be seeded. The seed is going to be table from columns. Plenty of curly brackets. 1 to n, and we're going to call it column number 1. That's the seed completed. Right. Of course, our custom function, it's like always a little bit the same. State goes to, state and index goes to what? Alright, here we're going to build our field formula. I need a double function, but before I start that function, I need a local variable, just a small one. I'm going to call it a header, and it's actually the text from I, which is just I in text format. I'm going to reuse it a few times. First function, what we're going to do is add a column, table add column, right here at the bottom. We're going to add state, call the column whatever is in the header, and we're going to say each, same list as in the seed, and that's table.add column done. The next function that we're going to wrap here needs the header variable as well, and it starts there, and it's table.expand list column, and that's the template done. Let's test it and give it a name right there. As a matter of fact, all template is already a useful function. It's actually the repeat variations function, yeah, but it starts from one, which is rather unusual. Let's amend that and generalize it. I'm going to duplicate the template. Of course, we're going to start from 0, so we shift everything down, just like in Power Query, 0 based. Voila. And then what I'm going to do here is generalize it a little bit. Offset, right, plus the offset quickly. If you want, you can do that all the time. I'm only going to do it here. Got 3 things, 3 parameters. Let's invoke it right away. That offset can disappear. All repeat variations is what we're going to call it, and frankly I'm gonna put that there as well. Okay, let's have a look. So this is the general case for repeat variations. It's the way we write our large numbers, of course, using various digits. We start numbering from 0 on the right side, increment all the way up to the number of elements, which in this case is called the base, -1. Then we roll over to the second digit and keep incrementing. We all know how the large numbers work, right? Fine. You can do like this. starting from 0, starting from 1, starting from whatever you like, and that's that. The offset is a small complication. I will not add it to the subsequent functions. All repeat variations done. Fine. Next up, let's do combinations. Start from our template again. Right, let's give it a proper name. All combinations. What do we need to do? How do we need to amend this function? Well, we need to amend it in a couple of places. Just the lists, but that's it. Here I need to put as an upper limit n minus k plus 1, which generalizes in the field function to n minus k plus I. And the lower boundary here in the seed one is okay, but in the field formula it is whatever is in the previous column plus 1. How do we do the previous column? Well, we take the entire record, we say a record to list, and then we say list.last, and this is all combinations done. This is how we refer to, well, whatever is in the last column. Remember that we're gonna reuse that entire function shortly. This is all combinations done. Let's go and check it out. We're gonna rename the application. So we have 10 4x4, 210 rows, which is correct, and it starts in the first record as 1, 2, 3, 4, and it will end into 7, 8, 9, 10. Yeah, that looks all right. This is all combinations done. Next, all permutations. Let's recycle our template. Give it a good name. All permutations. How do we need to amend? Well, the seed is the generic list, a full list. That is good. But the field formula, we're going to amend it in such a way that we remove duplication, that we remove repetition, because it's ordinary permutations here. Alright, so we need to remove whatever exists already. Oh yeah, well, we know how to do that. Right, current record, record to list, and then from the full list remove that second argument, that list. There's a function for that. It's called list.difference. Confirm, and this is all permutations done. Let's check it out. Maybe hard to believe a little bit. Let's rename this all permutations. Fine. So for 4x4, we got 24 records in total. It starts with 1, 2, 3, 4, and it ends in 4, 3, 2, 1. Beautiful. All permutations done. As a little bonus, let's do another one, and they're called derangements. Alright, I'm going to start from permutations because derangements are actually a special case of permutations. Let's rename it and I'll explain it immediately. If I go and look at all permutations, a special case for derangements is that the original position must change, meaning element number 1 cannot go to column number 1, element number 2 cannot go to column number 2, etc. All elements in the original position need to be displaced, deranged. It's a thing. I'm not making this up. This is no joke. It's not so difficult, but it's not a joke. Alright, so how do we amend this formula here? Well, first off, the first column needs to start from 2, not from 1, because that is prohibited. Next, we need to remove a little bit more than just the current record. We need to remove the current record and make sure that the running index I is not present either. So what do? We add a second list containing I, and we combine that with the current record using list.union, and that complete thing gets removed using list.difference from the complete list. This is all the derangements done. Yeah, but there's a problem. Allow me to show you. We invoke it, give it a good name, all the derangements, and yeah, in the fourth column there are nulls because, well, we've used up all the other numbers in the previous columns, and only 4 could be put here in order to avoid repetition, but we can't put it there because it's prohibited for derangements. So we need to remove those nulls because they're not useful. So that's how we do that, but there's a problem again. This is not generic. So what do? Well, we're going to use the functions we've used before. Record to list, list.last, and that's the last column again in the generic case, in a generic way, as you can see. So this function I need to reuse in my generating function. Copy that, and I'll remove that step. These two need to disappear. So we'll integrate that here. I'll do it as follows. I'll say let loop equals all of this in the function loop, click, done. This is all the derangements completed. Let's look at the result, and I say yes, beautiful table, all is correct. So there you go. We reuse this little template here, and we modify the list definitions and maybe take it to the next level for the derangements function. But this is how you generate all possibilities in a combinatorial context. That's the way I would do it, and the way I actually do it as well. So there you have it. I hope you like it. If you have another way of doing things, throw it in the comments. We can discuss about it. You can have your moment in the spotlight, no problem. And yeah, we can all learn from one another, of course. That is the intent. So there you are. Hope you like it, and I'll see you in the next video.